Today we are going to study Science and Technology Part 1st, Chapter 2, Periodic Classification of Elements. In the last video, we had already studied about the elements and their classification, Dobberiner triads, Newland's law of octaves, and Mendeleev's periodic table. In this video, we are going to take a look and understand modern periodic table. When Mendeleev put forth his periodic table, the interior of the atom was unknown. Later, after the discovery of electron, scientists started to find the relation between the electron number of an atom and the atomic number. Actually, in Mendeleev's periodic table, the atomic number just represented the series number of the element. In the year 1913, the English scientist Henry Moseley demonstrated that the atomic number of the elements corresponds to the positive charge on the nucleus of an atom, or rather the number of protons present in the nucleus of an atom. He demonstrated this by various experiments that he performed using X-ray tube. These experiments helped to reveal that the atomic number is actually the fundamental property rather than the atomic mass of an element. So, accordingly, the modern periodic law was stated as properties of elements are periodic function of their atomic numbers. In the modern periodic table, the elements were classified by arranging them in the increasing order of their atomic numbers. It became easy to predict the properties of the elements more accurately with the help of modern periodic table. Most of the drawbacks that were there in the Mendeleev's periodic table were removed in the modern periodic table due to the arrangement of the elements according to the atomic number. However, the confusion regarding the position of the hydrogen, that is whether it should be placed with halogens or the alkali metals, was still constant. In last standard, we had studied about the electronic configuration of an atom, how electrons are distributed in the shells, and the relation between the electron and the number of atom. This relation was easy to understand with the help of modern periodic table. Now let's study about the structure of the modern periodic table. Actually, modern periodic table consists of 7 horizontal rows numbered from 1 to 7, which are called as periods. Similarly, there are about 18 vertical columns numbered from 1 to 18, called as groups. This formation of periods and groups results in the formation of boxes. The atomic number of every element is indicated in the upper part of these boxes. Apart from these 7 rows in the modern periodic table, there are 2 more rows at the bottom of the periodic table, which are called as Lanthanide and Actinide series respectively. There are total 118 boxes in the periodic table, including these 2 series. The entire periodic table is divided into 4 blocks, namely S block, P block, D block and F block. Now let's take a look at the periodic table. The S block contains group number 1 and 2, while the group from 13 to 18 constitute the P block. D block constitutes of groups 3 to 12, while the Lanthanide and the Actinide series at the bottom of the periodic table forms the F block. The elements in S and P block are called as normal elements, while the elements in D block are called as transition elements. The elements in F block are called as inner transition elements. The three types of traditional elements, that is metals, non-metals and metalloids, are clearly shown in modern periodic table. Take a look along P block. The elements along the zigzag line, that is along the border, are metalloid elements. All metals lie on the left side of the zigzag line, while all non-metals lie on the right side. When it comes to the properties of the elements within the period, the neighboring elements differ slightly in their properties, while the distance element differ widely in their properties. The elements in the same group show similarity and gradation in their properties. The characteristics of groups and periods in the modern periodic table are based on the electronic configuration of the elements. The electronic configuration of the element decides in which group or period the element has to be placed. The properties of the elements changes slowly while growing from one end to another end, that is from left to right along the period. The elements in group 1 are called as alkali metals. The valence electron of all the elements in this group is same, that is 1. The elements of group 2 are called as alkaline earth metals. If we take a look at all the groups in the periodic table, we get to know that all the elements of same group have same number of valence electrons in their outermost shell. That is, all elements have same valency of same group. However, as we go down the group, the number of shells goes on increasing, as going from top to bottom within any group, one electronic shell gets added at a time. Now take a look at the figure 2.8. The electronic configuration of few elements is given. We find that the number of valence electrons is different in these elements. However, the number of shells is same across the period, as while going from left to right across the period, the electron gets added to the same shell. The atomic number increases by 1 at a time, and the number of valence electron also increases by 1 at a time. The elements in the same period have same number of shells. That is, the period number is equal to the number of shells of an element. The elements in second period, namely lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, have electrons in two shells. that is K and L. The elements in third period, namely sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon have electrons in three shells, that is K, L and M. For a shell, the electron filling capacity is given by formula 2n square. That is shell K, L, M, N takes value of n as 1, 2, 3, 4 respectively. So accordingly, the electron filling capacity for K shell equal to 2 into 1 square, which is equal to 2. Similarly, we can calculate the electron capacity of the other shells. The chemical reactivity of an element is determined by the number of valence electron in it and the shell number of valence shell. This information is obtained from the position of the element in the periodic table. Thus, modern periodic table has proved useful for the study of elements. Periodic trends in the modern periodic table. When the properties of elements in period or a group of the modern periodic table are compared, certain regularity is observed in their variation. This regularity is called the periodic trend in the modern periodic table. We are going to see the periodic trend in only three properties, namely valency, atomic size, metallic and non-metallic character. Valency. We had already studied that the valency of an element is determined by the number of valence electrons in the outermost shell, that is the number of electrons present in the outermost orbit. So, as the valence electrons are same for the elements belonging to the same group, thus the valency for the elements remains same of same group and goes on changing across the period. Atomic size. As we know, the size of the atom depends on the atomic radius. The atomic radius is the distance between the nucleus of the atom and its outermost shell. It is expressed in unit picometer, which is much smaller than nanometer. As we know, the shell gets on adding up as we go down the group. Thus the atomic size goes on increasing from top to bottom along the group, while it goes on decreasing from left to right across the period as the electron is added in the same shell, which results in more force of attraction from the nucleus on the electron. Metallic and non-metallic characters. We had already studied about the zigzag line in the p block, which separates metals from non-metals. Also, the metallic elements like sodium, magnesium are seen towards the left of the periodic table, while the non-metallic elements such as sulfur, chlorine are seen towards the right. Thus, in the modern periodic table, the metals are towards the left and non-metals are towards the right. The metals have the tendency to form cation by losing their valence electron. This property is called as electropositivity of an element. On the other hand, the nonmetals have the tendency to form an anion by accepting electrons from outside into its valence shell. This property is called as electronegativity of an element. The electrons in the inner shell lie between the valence shell and the nucleus. Because of the presence of these electrons, the effective nuclear charge exerting an attractive force on the valence electron is somewhat less than the actual nuclear charge. Thus, the number of valence electrons in metals is small, that is 1 to 3. Thus, the effective nuclear charge is also small, which helps the metal to lose the outermost electron and form cation to attain the stable electronic configuration, stable noble gas configuration. The periodic trend of metallic character of elements is clearly understood from their position in the modern periodic table. As new shell gets added up as we go down the group, thus the effective nuclear charge goes on decreasing, which helps in increase of metallic character down the group. While the metallic character goes on decreasing as we go from left to right across the period, as the electron gets added up in the same outermost shell, which results in the increase of the effective nuclear charge on the outermost shell. Thus, the electropositivity goes on increasing down the group and goes on decreasing from left to right in the periodic table. Similarly, the electronegativity goes on decreasing as we go down the group and it goes on increasing as we go from left to right across the period. This electronegativity is the tendency of an element to form anion, or electronegativity is the non-metallic character of an element. Gradation in halogen family. The group 17 contains the members of halogen family. They are represented by general formula X2. The gradation is observed in their physical state down the group. Thus, fluorine and chlorine, that is F2 and Cl2, are gases. Bromine, Br2, is liquid, while iodine, I2, is a solid. Do you know, when metal react with hydrogen dioxide, that is water, it forms metal hydroxide and hydrogen gas is released. A general chemical equation indicating the reaction of alkali earth metal is given here. As we know, when we go down the group, the reactivity of metals goes on increasing, and thereby the ease with which the reaction takes place also goes on increasing. Thus, beryllium does not react with water. Magnesium reacts with steam, while calcium and strontium and barium react with water at room temperature with increasing rates. This is the end of our chapter. Do study the chapter well and answer the exercise questions given in the textbook. If you have any doubt regarding this chapter, do ask in the comment section below. Do subscribe my channel and click the bell icon for notification. Do like and share the video. Thank you.